I want to talk about something that I worked on a couple of years ago, and it's a lesson I learned the hard way. And I want to share with you the importance of doing this. It can be really intimidating, it can be hard, but I think every step of the way, it's very well worth it. And that is to really be able to take to the last step and to automate the process of deploying code. So I want to talk a little bit about that, and then we'll talk about some of the reasons to do it, some of the benefits, and what are some of the concerns we need to be looking at. Generally, when I give this talk for a little bit of a longer period, I usually connect to a cloud, deploy things, and show. But I'm not going to do it that part here today, partly because of the shorter time on this one than I usually have, and also it's a little harder to do that with the network being a little bit brittle. It becomes really hard as well. So as a result, I'm going to mostly talk about it today than to do that last part of the thing that's demo. However, if you go to my website and look for this talk, you will be able to find the code example that's posted there along with this talk as well. So you can look at the code and take a look at what I've done in it as well. But let's step back for a minute. So when it comes to writing software, there is a funny thing that we do, and it really, when you look at it in a slightly different light, you realize the conundrum or the puzzle. If you ask any programmer, right, fundamentally, what do we do as programmers? Our job, you could be working in a construction-related domain. You could be working in a banking domain. You could be working in an airline reservation system. You could be working for a company that deals with medical information or radiology, whatever it could be. But what do we fundamentally do as programmers? Our job is to automate the world. That's what we've been doing. We automate the world. And yet, very surprisingly, we tend to really push back and be reluctant when it comes to automating what we actually do. That's the strangest thing. There's the saying that the shoemaker's son is the last one to get the shoes. And why is that, right? So we tend to keep our focus on our clients, our businesses, but what about us? And how do we automate things for ourselves? And I realized the reason to automate several years ago. But to me, programming principles and life have a lot of commonality. I can take the lessons I learned in my life and I can apply it to software development. I can take lessons I learned in software development and apply it back to life. And that becomes very enriching because I can work towards improving each one of them. But I will start with my very first learning, my very first lesson that really helps me to think about what I do consistently. And the first lesson I want to share with you here is this thing that I keep telling myself often, and that is make it work, make it better real soon. So I'm a huge fan of that approach. The minute I make something work and I have it done to a certain extent, I can come back and improve on it over and over and over, and I can get better. So make it work, make it better. When I was developing a software for my own company, it's easy to develop software for other people. When you work in a team, when you work in a large company, you do stuff that you are told to do. They tell you, here's the deadline, do this. And I'll be absolutely, I'm very shameless. I always, like to share my failures because that's how we learn. So when I was developing software for my own company, I'll tell you, I've been sitting and writing code and writing code and writing code, and my mind keeps telling me, this is not good enough. This is not adequate. You need to add these more features. You need to go back and review the features you implemented. You got to polish them. And I kind of step back, right? This is like the out-of-body experience. You leave Venkat and you step over and you look at Venkat, right? Sometimes we have to do that. We got to kind of introspect. And I said, what am I doing? And I realized what I'm doing is I am being fearful to release this product I'm developing. I'm holding on tightly to it. And I keep telling myself, next week I will release it. And the next week I found more excuses. You know what? Maybe one more week. And then I took a deep breath and I said, that's it. It doesn't matter. I'm going to release it now. And I took the time to release it. And it's like a burden was removed from my shoulder. And I'm not even kidding with you. The minute I released it, within a week, I made so many updates to the software. And those were quick because every little update I did, I was able to keep pushing it to release. And now I learned my lesson the hard way. Is what if I start by releasing the software first and then start building it? So it could be the smallest thing. It may not do a whole lot, but the minute you start releasing it, it becomes easier to keep building on it. And in our mind, we have this notion, we tell ourselves, oh, this is not production ready, but why not? Oh, this is not really what everything it can do. Well, but it does something. If I cannot provide value at a lowest level, what good is it? The other thing is, when I write code, I think of good software design principles. One of those principles is called the DRY principle. Does anyone remember what DRY principle is? I'm sorry, what was that? Sorry? Sorry, say again? He's still not getting it, is he? What is it? Sorry. You got it. That's all right. Yeah. So don't do that. So don't repeat yourself. I'm not going to say that again. So absolutely. I apologize for that. But it's always fun to pull people down a little bit, right? And then pull them up. So DRY principle is something we do. So what does DRY principle say? It says every piece of knowledge should have a single, unambiguous, authoritative representation in a system. So in other words, you want to be able to capture your logic, capture the essence, capture the configurations, capture the rules in a single place in a system, and don't duplicate it. But oftentimes, we think that DRY is about copying and pasting code. Yes, it is, but not only. That's only a small part. So DRY is more than copying and pasting code. It's about duplication of effort more than duplication of code. So I ask myself, what am I duplicating? And I say, I want to duplicate those things that give me intellectual pleasure. I want to duplicate it. I love solving problems. That stimulates my mind. When it stimulates my mind, I feel good about it. So I want to repeat solving problems. But there are things that are boring. They may be exciting the first time you do it. But the second time, the third time, the fourth time, it becomes boring. As an example, I have a spreadsheet. I have to make a change to the spreadsheet every week. I've got to sort the spreadsheet based on a column, and then I have to generate a PDF report after removing certain columns with certain sensitive data. Once I create the PDF, I've got to upload it to a server, and then I have to send notification to people, letting them know the report is ready. And I did this for about 7-8 years, every week, like an idiot. And one morning, I got really angry at myself. I said, wait, this is silly. Why am I doing these steps over and over and over manually? I need to be able to automate this. So I spent about 20 minutes figuring out how to write Apple script. I had never written Apple script until that date. But I learned how to write Apple script, obviously because I'm on a Mac. So I wrote an Apple script. And the Apple script now knows to open the file, to sort based on a column, remove the sensitive columns, generate a PDF, save it to the disk, SSH into the server automatically, update the PDF, send a notification while I sip a cup of coffee and think about meaning of life. So the point really is, I don't need to be doing those steps. I can automate it. But the beauty is, the first time I decided to do a little bit of automation. And you may be surprised, what is that little bit of automation? Well, you can see the Wi-Fi is connected. Maybe it is, maybe it's not, but it's connected. But I want to turn off the Wi-Fi in some situations, especially when I want to do certain testing. I want to turn off Wi-Fi, and then I want to turn it back on. And I realized what I was doing was clicking on that Wi-Fi button and turn off, clicking on it, turn on. And one day I said, that's kind of stupid. It is disrupting my flow. So I spent about 15 minutes, found how to automate turning on the Wi-Fi and turning off the Wi-Fi by running an Apple script that would issue the command from the command line. Then I typed the command line to a shortcut key on my keyboard. So I'm coding away, and my little brain says, turn off the Wi-Fi, and I just hit the shortcut key. It becomes a muscle memory, and the Wi-Fi is off. And then you're coding away, you want the Wi-Fi on, you hit the shortcut key, the Wi-Fi turns on, and now you're not doing that locally, but manually. But the point here is that little automation may not be a big deal, but every little automation leads you to a bigger automation, bigger challenge you can take. And finally, I will tell you, I would say, automation shall set you free. You are not there doing mundane things over and over and over. Then you're able to spend your time on a more productive activity that is enriching to your mind and what you really want to do. So just in short, I automate the heck out of things on my machine. That's what I do. And that really saves me a lot of effort in what I do. And the fundamental reason for that is the following. Testing code manually is a violation, you could say, of the dry principle. Think about that for a minute. If you test your code manually, it's a violation of dry principle. It doesn't have to be code level dry. It's a dry at the process level. And if you take that a little further, I would argue that manually deploying, you could say, so I apologize for that. It's a little awkward in this place for me to reach to the keyboard and type. That's what makes it harder here. All right, so manually deploying code is a violation of the dry principle as well. If I'm manually deploying code, my team is manually deploying code, well, guess what? That's a violation of the dry principle because we are repeating this over and over and over. But not only that, there are other consequences to doing this as well that we should really think about. So in a sense, you want to ask the question, why should I really focus on that kind of automation? But no means am I telling you this is easy when you start out, because there's a lot of difficulties ahead. But every step of the way when you do it, it's well worth it. So today, I've gotten to the point where I modify my code, verify my tests are passing, and I do a git commit, and I don't have to turn around and do anything else. Because the minute my git commit is done, it runs through a process, checks if the tests are still passing. If it does, it automatically deploys the application on the cloud and sends me a notification that it recycled the systems to have a new deployment in place. So the benefit of that is I don't waste my time on deploying applications. I just make changes and boom, it's done. And that gives me agility. So the moral of the story here is that truly when you think about it, right, what's the reason to do it? You could say automation gives your business agility. So you are truly agile because you're able to move faster. You're removing the chances of making errors things that would slow you down. And if done properly, this can give you that agility. That's one of the reasons. So when we deploy, we often have to deal with multiple moving parts. My application infrastructure contains a cloud environment where there are several parts that have to come together and work. When I upgrade things, several parts have to change. And the worst way to do this is to do it manually, because I will forget to make one change. And how many times each one of us has done that, right? We do something, and 5 minutes later, oh my gosh, I cannot believe I forgot that one. You know why? Because you're human. To err is human. We are creative, but we don't have the precision of a machine. So we shouldn't be doing those things that a machine can do better. And we have databases, application servers, third-party services. We got to worry about provisioning proper resources. We have to worry about security and so on. What about having these load balancers, the policies, the storage? Hey, this particular system, this particular area of the network should only be reachable from this network, but not from anywhere else for security reasons. What if I make a mistake doing it? I might open up for security violations, and that can be huge. How many times do you hear on the news, take a name of a company, put the name of the company, had a security breach, and every time you're like, here we go again. How can that be possible? Because somebody somewhere forgot a step. That's basically causing it. But what if we can really thoroughly check this and verify it automated? That can mitigate these risks. Upgrading when there is a change. What if I can get the change done very quickly? And I am in an airplane constantly. Every week I fly to some part of the world. But what I've really gotten used to these days is I love airplanes. Honestly, I do. You know why? Because nobody can call me when I'm in an airplane. This gives me anywhere from 5 hours to literally 16 hours of time when nobody bothers me. And I love that. Flight attendants always look at me like I'm weird. They say, do you do anything but work? And I'm like, this is the whole point. Don't bother me. I'm here not to be bothered, right? So I would flip open my laptop. I was traveling with my wife one day, and I didn't even realize it. We just came into the flight, and the guy next to me said, I cannot believe it. And I didn't even realize he was talking to me. And my wife kind of elbows me and says, he's talking to you. And I turned around to him and said, yeah. And he said, I cannot believe it. I said, what? And he says, your butt did not even hit the chair, but your laptop is open and you're working. I'm like, oh, thanks for observing. And I got working. And my wife is like, that's him, just leave him alone. And to me, that's the beauty, right? You can just sit there and you can have a flow, not be bothered. But these days, I write code, my test passes, I commit, and in a flight, which is like 5 hours long, I can easily do maybe a dozen small changes, add features, and commit. I was mentioning this the other day, and one of my friends noticed and said, do you realize what you're doing? I said, what is it? And he said, most of us deploy up to the cloud, but you deploy down to the cloud, he said. That's actually kind of true when I realized it, right? Because from 30,000 feet, you're deploying down to the cloud. But the point really is, you can automate your way through it, and so you're not wasting your time. I can get the changes out very quickly because I'm not wasting my time on those steps. What about database change, schema changes? The worst way to propagate a schema change is to manually deal with it. I cannot tell you how many companies, how many banks I work with where their teams of people waste weeks dealing with updating databases. And it just blows my mind. How many thousands of human hours you wasted doing this process instead of just spending maybe a week figuring out how to automate this stuff, and you don't have to do it manually. So things that change, like system properties or backend code that changes or UI code that changes or a service that changes. So in other words, everything keeps changing all the time. So if everything is changing all the time, how do you keep up with such a change? The worst way to try to keep up with the change is to manually try to go after it. You cannot sustain that pace unless you are wasting a lot of time and losing agility. So manual deployment, we have full control, we think, of what we are doing. We can fix errors along the way, but it's very tedious. It's very cumbersome. It drains you out. It's step by step. You have to follow these, and you forget one of them, you're in trouble. It's error prone. We miss things, especially when you have to deploy to multiple environments that may have variations. Oh my God, I forgot I got to do this on the system, but I got to do that on that system, right? That becomes painful. You first have, the first install is easy, but every upgrade becomes more expensive. It's also consuming time. It's costly. Look at the time your team spends on these things. If you want to save, be productive, start monitoring the time people take from one end to the other and how much waste we introduce. And it's very impractical if we ever want to get to CI/CD. And it's impractical if our services are elastic. How do you make it elastic if it cannot be automated in its deployment? It becomes harder. And it's impractical if our services have to scale. I learned these lessons the hard way. I had an elastic service, but it required a manual intervention. And everything was great until it was not. I was in a conference like this, giving a talk, when my server decided to take its last breath. And the elasticity broke. It's like a rubber band breaking on your hand, right? And I get calls from my customers saying, hey, dude, your services are unavailable. I was red-faced when I left my talk. And what did I do? I fixed it, I brought it up, and I said, never again. I learned my lesson the hard way. And what I did not do, I did not automate that last 5% of the step. I learned my lesson the hard way. It's that 5% that requires you to be there present. And since the time I automated that, the server had restarted hundreds, if not thousands of times. I don't even know. And I don't even know when it has restarted. Because it says, gosh, we need to restart this. Go for it. It's your problem, not mine. That's why you are elastic, so I don't have to keep an eye on it. But we take the time it's okay to make mistakes, but we learn from them and we fix them. So the question is, how to automate these deployment? How can we achieve it? Should we use UI wizards? I hate UI wizards because if you're going through the UI, click, 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 that's so a mechanical and manual process. That's boring. That's not intellectual for me. So I don't want to go through a UI and start setting things up. And that could be a first initial step. Again, remember, make it work, make it better real soon. If you've never done this before, you might say, hey, I need to really go work on this, see how it works, and then I'll come back and I will automate it. Not a bad idea. That's okay. But that's not the end goal. That can be the initial first step for you to know how things work and understand. What about writing code to deploy your application? So if you're able to write code, and if the code you're writing is helping you to deploy your application, now we are moving towards automation, and we can start figuring this out. So the benefit is it's easier to make the changes, and it's easier to deploy the changes. It is less time consuming because you removed a part of the process from your shoulder, and it's less error prone once you verify these steps are actually working. And again, I don't know if you are like me, but I am extremely error prone. If you tell me, do these steps perfectly, it's very hard for me because I am not good at these mechanical steps. I cannot say, I followed step 1, I'm following step 2, I'm following step 3. I will miss things along the way. Why? Because my brain is always on fire. It's thinking about something else, not following instructions to that level. I'm not a machine to follow instructions. So as a result, I make mistakes during deployment, but that costs money, that causes embarrassment because things don't work once I deploy. But if I automate it and verify the automation is working, I can then don't have to worry about it. But it requires extensive planning and organization. If I don't have the skills to do it, let me emphasize that, not if I don't have the skills to do it. I did not. Because I'm a programmer. I'm not a DevOps person. But I'm also a small business. That means I'm everything at some time. And okay, everything except accounting. I can't do that. So the point really is you have to figure out how to do things. But knowing it's a skill, you take the time to develop the skill if it's worth it, or hire somebody who has those skills if you're not willing to do it, or if your time is well spent elsewhere. And that's a fair game as well. And it requires programming ability. This is where whoever is involved in it needs to be able to write code. They may not write your Python code or Java code or JavaScript code, but they're writing code. But they're writing code for a different purpose. They're not writing code for the application logic, but they're writing code for deployment purposes. And that's their job to be able to provide it. So they need to be good at this kind of programming, and they need to learn it. But the first benefit is dry, as I mentioned earlier. It allows you to remove the duplicated effort of manually deploying code over and over. That's one of the first benefits we get out of it. The second benefit is consistency. When you have multiple of these instances, multiple environments, you want to be able to be consistent in how you deploy across these environments. This gives you the ability to be consistent across all your environments so you don't have to worry about missing things. And it's easy to distribute this across multiple environments, but across regions as well. When I deploy it on the cloud, I ask it to deploy it on a certain region, but I can also ask it to deploy it in a different region. So if there's a network partitioning, I can have availability of my application for different regions. But if I were to do this manually for every region, now I multiplied my cost and effort as well. This allows me to scale my deployment across multiple regions and across instances within the same region as well. That kind of ability you would rarely get by doing things manually. And is an executable form of documentation. Let me spend a minute on this. This was a while ago. I was on a project for a client, and we had something deployed on a particular machine, and we had to make a change to it. And we made a change to it. We had to redeploy it. And I came along and I said, we need to redeploy it. And that's when my boss said, oh, the guy who worked on it no longer works here. Okay. And then my boss said, but don't worry. The last week before he quit, I made sure he wrote a documentation on how to deploy. And I said to my boss, good job. At least, because I was going to ask you, do you know where he is? We can call him and ask him. But good job, you asked him to write a documentation. Thank you. Well, we have programmers who modified the code. That was not the problem. But I didn't deploy this thing. So I took the documentation and I started walking through it. And several of the steps in the documentation no longer work because the environment has changed over the time. And now I'm like, sorry, boss, you had good intentions, but this documentation is stale. It's no longer working. So the worst way to document anything is to write it so humans can read it because it's going to get obsolete. How do you know it is still working? How do you know if it's still relevant? So I told my boss, really sorry, I need more time on this because I got to figure out how it's going to work. And so I did. I fixed it. And my boss came to me and said, good job fixing it. Now can you document it? This is what Einstein said, right? What did Einstein say? Doing the same thing over and over and expecting a different result the next time is the definition of insanity. Hey, you had a dude write the documentation, didn't work. Why would you want me to write the documentation again, right? Again, he's not entirely wrong. But we have to ask the question, I need a documentation because I need to leave a trace for the next person to pick it up. Good. But so I want you to write this in Word. Bad. So what I said was, no, boss, I'm not going to write a documentation. I'm going to create a script. And the script is going to play out a story. And the script is going to echo on the screen, I am doing this step. And then it will do the step of deployment. And then it will do the next echo and do the next step. And I'm going to put this step into the script into a automation system. And anytime the code changes, that script will run. And it'll execute it and perform the deployment. That became an executable documentation. It's documentation because it tells you the story. It tells you how this needs to be done. But it's not a stale documentation. It's an executable documentation. What if the environment changes? How does it change? Because somebody is modifying something somewhere. And when the script runs, you get a notification today. And you're like, oops, that one failed. Hey, what's different now? Let's go fix it. The documentation is up to date all the time. So when you quit and somebody else takes the job, you're leaving something more useful for them. To me, this is a professional commitment. I don't want to leave a place and learn that the building burned down on fire because I didn't care to really do a good job. That's not a professional. A professional is one that leaves a place and gets to know years later they're still using what you created and it's doing great. And so I want to make sure I'm going to leave, absolutely, right? Nobody's going to be in a place forever. I'm going to leave. But when I leave, I want to leave something that sustains, that lives beyond my time over there. And how do we do that? That's one approach to take care of it, is to create that executable documentation that can be useful. So as a result, developers and DevOps can both verify the configurations for consistency. As a developer, you can say, here is the requirements we have. Here's the number of threads you need to configure. Here's the amount of memory you need to provide for this application. But how do you know those things are being provided in the production? What if you get a call saying something's not working and you're like, gosh, we tested this, it worked, but in production you didn't give enough resources for it. How do you verify proper resources are given actually? That can be part of your system's configuration that you can verify as well to make sure it happens. And it removes those ad hoc changes. We all have done that, right? A little change here, I made that work and I totally forgot about it. And the next time you want to redeploy, it's not working and you're not sure why. And this again, I would say, is something we need to take the time to understand. I'll share with you one story, right? I said I will, not hesitate to talk about my failures. But I will also not hesitate to talk about my successes as well. Because to me, this is what motivates me to keep learning. I was a very young programmer. As you can see, that was in the last century I'm talking about. And I was fresh out of school. This was my very first job. And I was in my first job, and we were using a database, and the database vendor had just released a brand new version of the database. And we got a copy. And back in time, some of you may not know what this is called, but we used to get discs, like the 3.5-inch discs. You probably have seen them in museums. And so we got a boatload of discs, and you install them, and install the software, the packages you want to install. And we did. And then I was the programmer writing code. And I ran into a situation where the code wouldn't really work, wouldn't even compile properly in a certain situation. And I'm like, gosh, this is not compiling. But I'm not the guy who tells people it doesn't compile. When something doesn't compile, I get curious. I'm like, why doesn't it compile? So I'm now digging like 7 levels deep into the database code. And I found out, and I don't know how they passed this, I found out they had an error in the template in the database, one of the headers. This was a C++ project. And I found what the error was. And now I'm like curious. So I'm modifying the database code. This is a third-party vendor, right? I'm modifying the database code. I recompile the code and I rerun it. And I made sure everything is working. And I'm like, yes, it's working. I found the issue, right? And the next thing I called the database vendor, I said, hey, and I kind of know them a little bit because we've had a good communication over time. And so we were kind of knowing each other. And eventually they gave my contact, their contact, and said, if you got any problem, call me and I'll help you. So you're on like a first name basis. So I called this person in California and I said, hey, I got a problem in the code. I found it. I can even tell you where the problem is, and maybe you can help fix it. And he's like, sure, what did you find? And I'm telling you the file number, the line number where to look for. And I said, on this line, you see this, but if I change it to this, it'll work. He said, hang on a second, let me take a look at it. And then he thinks about it and says, oh my gosh, I don't know how this slipped through. You're absolutely right. That's wrong code. Thanks for reporting it. We'll take care of it. I said, oh, thank you. When will you send me a patch? And literally this guy said, okay, I don't understand what you just said. You found the problem. You fixed the problem. And now you are telling me I need to send you a patch. Why? And I said, well, the reason is very simple. I know how to fix it now, and I will walk around to everybody's machine and I will fix it. And then I'm going to be on a vacation, maybe 6 months from now. On that fateful day when I'm on a vacation, somebody takes this disk and reinstalls the code on a machine, and nothing works. And my company just wasted who knows how many thousands of dollars fixing this. And before I could finish my sentence, it's like, you know what? I stand corrected. You're right. I will have that sent to you right away. And the point is, now we can publish and say, we no longer are using 4.1.3, we are only using 4.1.7. That kind of documentation will reduce your cost. So never do ad hoc things in software development, because when you do that, it's going to cost you thousands of dollars later on. And that's when you begin to realize, how did we end up wasting this money? It's because somebody took a shortcut. And there's that saying, right? What is that saying? There is no longer path than the shortcuts you take. Remember? That's actually so true. And that's why you got to slow down and say, no, let's do this right so we don't waste time and money later on. That becomes very important. So it can help us to remove these ad hoc steps in general. Can be version controlled to monitor change history and regression. By the way, my automation deployment code is part of my version control. When I modify it, it gets versioned to the same Git repository. So I can go back and see what has been changed, and I can keep a diff, and I can see the evolution of it as well. So this is code. Give it the respect of the code. Like every other code, it has to be in version control as well. That's essential. You can test it like every other code we do. And it's easy to implement a shutdown process as well. I have something on my system. I did this about a month ago, where my server is running, but when my server reboots, I need to make sure all these services are started again. And so I've written some scripts, automation scripts, that wake up as soon as the system reboots and has those services up and running. And that is something you can automate, so you don't have to worry about what services restarted, what did not shut down and restart properly. You don't have to worry about that as well. And you're able to scale this to a fairly large infrastructure. To me, one of the biggest reasons I like to do this is that point. It improves the speed of deployment. I don't have to waste my time deploying. It gives me the ability to focus on what I do the best, is to keep adding features that are relevant to my business. And I can leave the automation to the script. I don't have to do that manually because it's been done once. And we talked about these earlier. Reduces the cost, reduces error, reduces the chances of failures as well. And you're able to be consistent and frees up your team's time to focus on your business needs. If you ask me, why do you automate, Venkat? Very simple. So I can be here talking to you. I can be focusing on my business. I can be writing features. I was on a Friday evening, I got an email from somebody, and they said, I'm using your application. I'm trying to do this, and it's not allowing me to do it. Can you please take a look at it? I usually wake up early, so it was early Saturday morning. I saw the email, and I said, yeah, I know why this is not working, but if the user wants to do it, who am I to stop that? So I made a change. It replied to the email and said, hey, thank you for letting me know. Could you please try it again? And later that evening, I got an email from them saying, hey, thanks for taking care of it. It works really nicely. And then they went on to say, the speed at which you made this change makes you wonder maybe you're using AI. And I said, well, I wish I was using AI for this, but it's actually good design testing and automation. So sometimes it can feel like, oh my gosh, you're super fast. That means you're not doing human things. Well, yes, it is true. I'm not doing everything manually, but that doesn't mean it's got to be AI either. There's a good set of practices we can put in place, and that can help us a great deal as well in getting the results if we want to. So we can free up the time so we can actually focus on things. The question is, how do we write these scripts? There are two separate approaches. Neither one of them is right. Neither one of them is wrong. It's entirely up to you how you want to progress. So when you look at a tool, you can ask the question, which kind of tool is it? One is imperative and the other is declarative. So what is imperative? Imperative is where you provide step-by-step instructions and you say, do the step 1, do the step 2, update this file, change that setting, and you are telling it every step of the way the things it needs to do. That's imperative. You can say, move this file 1 to file 2, move this file 2 to this location, move file 3 to this location. That is imperative. Now, on the other hand, you have really good control and visibility as to what you're doing, but you have to manage the changes yourselves. What is declarative? You provide the details of what's desired, and the steps are written by the tool for you behind. Let me use the same example to tell you what I mean by that. Imagine that we have a bunch of files here, and you want to deploy those files to here. Here's my imperative way of doing it. I can say, if this file exists there, and if the timestamp is the same, don't copy it. This file is there, and the timestamp is different, copy it. This file doesn't exist, so copy it. That is imperative. I'm step by step saying what to do. How can this be declarative? I can say, here is directory 1, here is directory 2, go. That's all I said. And the directive says, oh, you are asking me to do a diff on the directories. Thank you. I know how to do it. And it goes through, compares the files, and makes a copy. So you're not telling step by step how to do it. Instead, you're giving an instruction at a higher level, and you're saying, go take care of this. If you want a little bit more about imperative versus declarative, you can write a for loop. In your for loop, you can say, for every name in the names collection, write a div tag where the name appears within the div. That is imperative. You're looping through every name, creating a div, and updating the name in it. That is imperative style. But what do you do in a cascading style sheet, CSS? In CSS, you didn't say, find this element, look for this property, change it. You simply said, if this is a class, I want to use the style. If this is the ID, I want to use the style. Who then makes the change? Well, the browser walks through your CSS and says, oh, you gave me the classes over here. I found a class here in an element. I'm going to apply the style to the class. That's an example of declarative. So cascading style sheet is an example of CSS, of declarative. Whereas the Angular code, the React code, you may do to loop becomes an imperative style of writing the code at that part of looping, not at all the way to the higher level. So you could have tools that do either one of them. So what could you do? You could tell your tool, hey, here are the security credentials. I want you to deploy this security credentials, settings, provisioning for me. How do you do it? The tool says, step back, relax, I'll take care of it. You just specify what you want. Don't tell me how to actually do it. So you're not instructing the actions on it. You're simply saying, I want your end result to match that. How do you match it? That's your job, tool. That's declarative. So declarative, you provide the details, the tools figures out the details, less visible into what is actually going on, but it's easier to configure since you focus on the goal rather than on the steps. So this is just two different schools of thinking, and you could be comfortable with one or the other. Generally, I am a fan of the second one. Why? It's less work, right? I can simply say, here you go, I tell you what the details are, you take care of doing the work, actual work. But it depends on the scenario as well, and you may gain more control or not, depending on what you're doing. So in terms of automation, you can automate various things. You can automate your workflows. So your workflow, you may have to go through a sequence of steps to do certain things. You can automate those steps. You can even add variations through it. And a logic that says, if this is true, do these steps, otherwise do these steps, you can implement those as well. You can do orchestration through these also. You could have systems that take a series of tasks and walks them through in terms of deployment. For example, I might have to first spin up a database. I may have to push a schema onto a database. I may have to then set some security credentials. I may have to create some users. I may have to then create some services. I may have to tell the services what the information it needs to access the database. Those are the steps you can automate for it to go through that process of doing in a certain order, if you will. You may deal with provisioning. You may say, hey, here is how much memory I want to allocate on these servers. Here is the configurations I want to provide for these. Here's the number of amount of a hard drive space, disk space I want to provide on these. Those are your provisioning in terms of what you provide. You can configure those. And deprovisioning as well. What if you realize you have maybe over-provisioned this? You don't need that much and you want to reduce. You could provide that as well in your systems. Now, I will share with you options, and then I will share with you my opinion about this. When it comes to deployment, there are two ways to do it. The answer is very simple. Which way you choose depends on how much pain you want for yourself. Maybe a nice way to think about it. One approach is called a mutable approach for deployment, evolution, and the other is immutable. So what is mutable? Mutable is where you have a service deployed. Let's imagine for a minute that's your service. And you decide this service needs to be updated. So what do? You have a newer version, and you have these binaries and all the details. So you kick this out, and you put the new one in place. What's the benefit? The benefit is you did not use any extra resources. How much money is it costing me to deploy it? It's the same amount of money you are spending. You did not increase the cost. You did not decrease the cost. Assuming you pay for that space, that's all you paid. You didn't use anything extra. What are the downside? Right? Trade-offs. So you didn't spend anything more. That's a good thing. So you're using fewer resources. You change in place, but you can render part of the service being unavailable. Imagine this for a minute. If somebody says, hey, we need to upgrade this, and I'm in the middle of the talk, they say, dude, stop. And I'm watching them remove it and put a new one in place, right? That disrupts the service. So if your clients are using, oh, this is my favorite, and I'm sure you all have seen it, right? I go to this particular website, and there's a message that says, "Dear customer, sorry, the service is not available between 2 a.m. and 4 a.m. on this Sunday morning." And you may say, "Venkat, why are you seeing that? You're supposed to be sleeping 2 a.m. to 4 a.m. on a Sunday morning." Answer one, that's my right, not the right of the company. Second, I am in Europe or India when I'm seeing that message, and it's not 2 a.m. in Europe or India. That's when I get angry, because my services are in the US, but I travel to Europe very often. And I cannot tell you how angry I am, because I am exiting the service, and it could be 8 a.m. or 9 a.m. on a Sunday, actually more like 2 p.m. on a Sunday for a 2 a.m. in the US. And it says, "Sorry, you cannot access this because it's not available 2 a.m. to 4 a.m. But what are they doing? They are changing. That's how you know that their deployment is mutable. They're removing the service, and then they're putting a new one in place. So that's one of the problems, that you can render the services unavailable. But there is a risk of failure to restart. Raise your hand if you have ever been in this situation ever. You have something running, you made a change to it, and the damn thing will not start up again. Happened to you ever? And when you are, that moment has a name in English, right? It's called panic. True? You're like, "Oh," and I won't say the word here, right? "Oh, blank, oh, beep." And you're like, "This is not working." What's the worst thing that can happen when your server has failed? It's not coming back up. I'll tell you what the worst thing is. It's my boss walking in and saying, "Do you know the server is not working?" I'm like, "Leave now. Please don't talk to me right now, because you just took me away from fixing the problem. And now I'm answering you rather than fixing it," right? So the point is, you never want to be in that situation. Okay, you want to be in that situation once. And then you say, "Never again." You want to taste it once, so you can tell the next generation, "When I was a programmer," right? How else? I always say this: the tragedy in production is the comedy in conversation. It always is, right? This is what you do when you go to parties, right? "Hey, let me show you my scar." "Oh, no, let me show you my scar," right? Where do those scars come from? If you've never failed, what have you done? "I have no scars." What a boring life you live, right? You want to show your scars, but where do you get the scars if you never, did stupid things to get the scars? So when you have those tragedies, you can go share your stories in those conversations, right? And then we can just laugh about it, but we're definitely not laughing when the production server is down. So the point is, this is why I said I'll share with you my opinion. I refuse mutable evolution. I don't do that. Because I've been there, done that, never to do it again. I've learned my lessons the hard way. And I've got scars in way many parts that I can share with you here. So the point really is, yeah, it's cheaper. But guess what? The word cheap, there's a reason why we say cheap rather than less expensive. It is literally cheap. Because when your server doesn't work, when your clients call, you ask the question, did you really save money? So to me, that money I'm going to spend extra is okay, because that's still less comparison to outages. If you say, oh, my business doesn't care if it's unavailable, well, who am I to then challenge that? Not a problem. So it depends on the business, to be fair, right? If your business says, let me ask you this question. Will you be able to be part of an organization where your organization creates bad software, it works only sometime, it fails, loses data, it's miserable, and every user is angry using it? Will you survive as an organization building such a software? The answer is yes. That's called the government. Right? No other organization can survive. If you're a private business, boom, you lost the business. Government is like, keep talking. Because you're a captive audience for the government. Everybody else, you're like, bye. I'm going elsewhere for my business, right? But the government is like, keep trying. So this is why we should be in the public sector. Or maybe not, with things that's happening in my country, right? Never mind. Let's say I'll not go there. So, Doge, okay. So, Dodge actually, not Doge. So, immutable, that's where I want to be. So what is immutable? Immutable basically means that you do not destroy a service that's running. You leave it running the way it is, and you want a new one, you put the new one in place. Bring it up. Is it working? No, shut it down. You didn't lose anything. Those calls didn't go through, you tried it with a little bit of users, shut it down. Hey, what about the existing service? Keep going. No disruption, right? That's awesome. You spin another one. Is that holding up? Is it working? Yeah, it seems to be working really well. Good. Now start killing these. So never kill an existing service to replace with a new one. Spin a new one. Let it stabilize. Check its health. Make sure it's healthy. And once it is healthy, start shutting the other ones down. You're not disrupting your service, but you say, whoa, wait a minute. This was costing X amount of dollars. You spin this up, I'm paying 2X. And then I'm killing this one, now I'm paying X. So when I monitor my bill, that's my cost, that's my cost, that's my cost. And guess what? I'm very happy for that because I don't have panic. Are there times this doesn't work? Oh, yes, for whatever reason. And I'm like, shut it down. Now I'm saying, let me take the time to figure out what's going on. I'm not in a panic, rush. When this is down, what do you do when you're panicked? Thank you. You make more mistakes. That's exactly right. And you're like, boom, deploy it. That doesn't work. Boom, deploy it. That doesn't work. Eventually, it worked. And we wasted all the time. Now, when I'm in an immutable environment, it doesn't work. I shut it down. Let me think. Let me understand. Let me put a proper fix in place. I'm not stressed out. And again, this is not just about reducing stress. It's about reducing the consequences of stress. That's more expensive to the business. Stress is expensive to my health. But the consequence stress of the business is high. And you want to reduce that. So this is where my preference is. Immutable. It is expensive, more expensive, right? But not when you compare the overall cost. So uses more resources. Existing service infrastructures are not touched except for deprovisioning. Greater availability, less risky, slightly increased cost. It depends on how much time it takes. For some of the services I have, that time can be 5-10 minutes. So for about 5 to 10 minutes, I've got double the amount of things running. And after 5 to 10 minutes, if these are stable, that goes away. So for 5 to 10 minutes, I double my cost. And then it comes back to what I'm using, right? I'm looking at my cost, and it's doing this. But that small cost is much less than the downtime and the panic and unavailability of service where my customers cannot purchase the products during the time. Loss of reputation, right? They're like, I wonder if this company is good because half the time their services don't work, right? And reputation also matters. That's something to think about. So what are some of the popular tools to do this? Typically, tools like Chef, they orchestrate their agents, and you can perform them on different systems to implement the workflows. They give you what are called cookbooks and recipes, a tool called Puppet. A lot of people use it as well. And it's very declarative in nature, as I talked about, imperative versus declarative. And you can orchestrate agents again to perform these workflows. Ansible, you can direct things using XML-like syntax, imperative in nature, and you can continue with complex orchestrations using these again, choices, right? So many choices. Terraform, very declarative in nature, but what I use is mostly these very specific cloud provider tools, depending on the cloud I'm using. And I'm not trying to say the word here, so I don't market any particular cloud. So essentially, that's what I mostly use for my own purpose, are fairly cloud-specific tools that I can use to provision on those environments, and so we can deploy on those as well. So that's basically an idea of how I spent more time explaining and encouraging why, and we also spent a little bit of time talking about the do's and don'ts as well. Like it promised, if you go to my site, you can download this presentation's template, but also the code example is there as well, if you want to just take a look at it to get a feel for it. And I hope that was useful. Thank you.